Today we're going to play a game. I'm going to start this timer, and then every 24 seconds, we're going to clap. That's right, we're going to clap. If I don't hear you clap, I'll be very upset. And every 45 seconds, we're going to get up and jump. That's right, you are going to get out of your chair and jump, because you know what? You could use the exercise. So could I. And we're going to keep doing this, clapping and jumping, until we clap and jump at the same time. Ready? All right, here we go. And begin. This is really boring. I don't like waiting. How long is this going to take? How long will we be waiting to jump and clap at the same time? Oh, I hate waiting. Well, I know something we can do. We can try to figure it out. We can just try to figure out how long it's going to be until we jump and clap at the same time. I didn't hear you clap. Come on, you got to clap with me. All right, we're going to figure this out. We're going to figure this out with math. We clap every 24 seconds. 24, 48, 72, 96. Those are the multiples of 24. We jump every 45, 45, 90 at the multiples of 45. So we're looking for a number that's a multiple of 24. Woohoo! And wow! Did you see that screen shake? That's what happens when we all jump at the same time. The whole world moves. Cool. And we kind of have an idea what we're doing in this problem now. We're looking for a number that's a multiple of 24, so we're clapping, and a multiple of 45, so we're jumping. We're looking for a common multiple of 24 and 45, and we want the first one. That's the least common multiple. Yes. So how are we going to find that? Well, we can start off just by listing out the multiples of 24, and we'll list out the multiples of 45 and find a number that's on both lists. All right, so let's do that. We'll start with 24. So you have 24, 24 times 2 is 48, 24 times 3 is 72, times 24 times 4 is 96, and 24 times 5 is 120. I could keep going, but this is boring too. You know what? Making lists is boring, waiting is boring, being smart, that's not boring. So let's be smart here. We're multiplying integers. That's a job for prime factorization. Prime factorization of 24, well, that's 3 times 8. 8 is 2 cubed. Now, I don't want to start over finding prime factorization of 48. I have a shortcut. 48 is just 2 times 24. I can multiply this by 2, and I will get my prime factorization of 48. Yes! All right, we're going to solve this problem. Get the next prime factorization. This is easy. 72 is 3 times 24, so I just multiply this prime factorization by 3. And that gives me 2 cubed times 3 squared. 96, we just multiply 24 by 4. 4 is 2 squared. 2 squared times this gives us 2 to the 5th times 3 to the 1st. And we keep on going, 120, we just multiply this by 5. And check this out. All we're doing at each step here, to find the prime factorization of each multiple, we're just multiplying the prime factorization of 24 by some integer. So each of these multiples, its prime factorization has to have all these 2's and this 3. Yes! The prime factorization of any multiple of 24 is going to have at least 3 2's and at least 1 3, because to make that prime factorization, to make that multiple, all we do is multiply 24 by some integer. That's awesome. We can solve this problem now. We've got the prime factorization of 24. 24 is 2 cubed times 3 to the 1st. And we know that any multiple of 24 is going to have at least 3 2's and at least 1 3 in its prime factorization. This is going to work. We can do the same thing with 45. For 45, and get all the multiples of 45, well, you know, that's when we jump. All the multiples of 45, well, we can find the prime factorization of 45. 45 is just 9 times 5, that's 3 squared times 5 to the 1st. Every multiple of 45 is going to have at least 2 3's in its prime factorization and at least 1 5 in its prime factorization. Because all we do to get a multiple of 45 is multiply 45 by some integer. So now we're interested in the numbers that are multiples of both 24 and of 45. Well, we know that for a number to be a multiple of 24, we need at least 3 2's in its prime factorization. Yeah, this is going to work. This is going to work. So we're going to try to build the prime factorization of the least common multiple of 24 and 45. Yeah, this is definitely going to work. We know that we need at least 3 2's for 24. And we need to have a 5. We absolutely have to have a 5 in this common multiple in order for this common multiple to be a multiple of 45. So we got enough 2's. We have a 5. What about the 3's? Well, I know that I need at least 1 3 in order to be a multiple of 24. And I need to have at least 2 3's in order to be a multiple of 45. Yeah, this is right. We must be getting close because we clapped and jumped very close there. So if we need at least 2 3's in order to be a multiple of 45 and at least 1 3 to be a multiple of 24, well, 2 3's will do it. We only need 2 3's because that'll take care of both. A number with 2 3's in it can be a multiple of 45. It can also be a multiple of 24. Yes! All we need is 2 3's. So we need 3 2's, 2 3's, and 1 5. And look at what we've done here. We looked at the prime factorization of these, and we took the highest power of 2, the highest power of 3 we see, and the highest power of 5. And sure enough, we get this. 2 cubed times 3 squared times 5. That's our prime factorization of our least common multiple. 2 cubed is 8. 8 times 5 is 40. 40 times 9, yeah, 360.